the collision means, while deriving one-dimensional elastic collision, we got equation number 3. What is the equation number 3? u1 minus u2 equal to v2 minus v1. Relative velocity of approach before collision equal to relative velocity of separation after collision. So from this equation, we can remember this coefficient of restitution. So what is the small e? How it is going to be defined means. So v2 minus v1 divided by u1 minus u2. So u1 v1 initial velocities before collision u1, v1 final velocity after collision, u2 initial velocity of second object before collision, v2 final velocity of second object after collision. So this is the equation or definition for coefficient of restitution. Some people will replace this with minus also. Minus v1 minus v2 by u1 minus u2. Both are going to be same one. So for perfectly elastic E value is going to be 1. Therefore, you got in that one-dimensional elastic collision this equation. If you keep 1, you will get same equation. For perfectly inelastic, E value will be 0. If you put E value 0, you will get V2 minus V1 is 0. This implies V2 is equal to V1. This one only we said in inelastic collision, final velocities are same after collision. So in between, neither elastic nor inelastic. Then E value will be in between 0 and 1. So this is about coefficient of restitution. If an object is dropped from h1 height, after bouncing back, it is rising h2 height. It will be rising here only. But for our convenience, I am showing here. Object dropped from h1 height, it is rising to h2 height. Then what is the coefficient of restitution, they will ask. So in this, one object is falling downwards and second object is ground. So ground velocity before and after collision, it is 0. Now what is the initial velocity whenever it is touching the ground means u1 is equal to, an object is dropped from h1 height. What is the initial velocity? Root 2g h1. If it is rising to h2 height, final velocity